G'day and welcome to the video as part of the Trigonometry series, and this one is angles of elevation and depression, which is exercise 5.4 in your textbook. Let me give you a little diagram here that kind of tells you what elevation and depression are. It's essentially just the measure of an angle, and the best way I can describe it is if you've got something here, the captain of the plane, for instance, is looking straight ahead. If he looks down at this person down here, the angle of depression will be straight out from the horizon down to this line here, looking at the person down below. So that's the angle of depression there. A lot of people think that this angle in here is the angle of depression, but it's actually this one here. So angle of depression is straight out onto the horizon, then down to the object that you're looking at. And likewise, the person standing down here looking up at the plane, if they look straight out onto the horizon, like there, and then they look up to the object, that's the angle of elevation just in here. Okay, so we must make sure that we label these ones correctly, because otherwise we'll end up getting the wrong angle or the wrong answer. So elevation, when looking directly out parallel to the horizon, so out here, look up at the object. That angle in there. Depression, when looking directly out parallel to the horizon, this way, then we look down at the object, which is this one down here. Okay, I'll give you a couple of examples to kind of help you understand this one, because it can be a little bit tricky. Here I've got a great drawing, and of a hill with a windmill on the top of it. Looks like a great windmill, doesn't it? There we go. Petro is standing 130 centimetres from a windmill on top of a hill. If there's an angle of elevation of 19 degrees from his vantage point, how high is the top of the windmill from the ground if he is 1.8 metres tall? So let me just draw a triangle to distinguish what's going on here. We've got this triangle happening just here. Okay, and this is the person's eye. And that's the top of the windmill up there. I can really draw these things very well. It's 137 metres from there, and we know that the angle of elevation is 19 degrees. Elevation from Petro, which is here, that is 19 degrees. Okay, so he goes straight onto the horizon and then looks up. That's 19 degrees. And we know that he's 1.8 metres tall. That will be important a little bit later. But first, I want to know how high the top of the windmill is from the ground. That's essentially this distance here. Okay, so I'm going to use trigonometry to find out this. This one is the hypotenuse, so that's a right angle. That one's the hypotenuse. This is the opposite here, and that's the adjacent. So I'm going to say tan of 19 degrees equals x over 137. Okay, using my ratios and all that sort of thing. So now I'm going to multiply both sides by 137, so I get 137 times tan 19 equals x, and then I can find out what x equals. Okay, I'll just go to my calculator to do that, and I get 137 times tan of 19, and the answer should be 47.17, corrected 2 decimal places. So 47.17. That's not my final answer though, because that's just the answer from my eyesight, or from Petro's eyesight, up to the top of the hill. We actually also need to add the height of Petro as well. So it's actually 47.17 plus 1.8. So x equals 47.17 plus 1.8. So x equals, now I showed you this in class today, but if you want to add 1.8 to this, I don't want you to do 47.17 and then do plus 1.8, because you might have made a rounding error or something like that. So instead, I want you to go up here, highlight the thing that you want, and either push Control C, copy, and then Control V to paste, or you can just push Enter, and it drops it down like this, then add 1.8 to that. Okay, and then we get an answer of 48.97 metres. Oh, I better recharge. What was it again? 48.97 metres high. That's how high the the actual mountain is, or the top of the windmill is from the ground where Petro is. Okay, I'll show you just one more example and then we'll finish. Okay, here's example 2. I was recently in the city standing at the top of a very tall building. In fact, it was 187 metres high. And I could see a boat out on the bay. Considering the angle of depression was 35 degrees from my vantage point, how far in metres was the boat from my building? So let's draw this illustration. So we've got a building with me somewhere there, very nice, just suspended in the building somewhere. And I know that that is 187 metres high. So 187 metres. And I looked out and I saw a boat in the bay somewhere. So here's the bay. There we go. And I saw a boat. Something very similar to that, kind of. And I knew that the angle of depression was 35 degrees. And I want to know how far this boat was from the building. So I want to know this distance just here. Okay, the angle of depression was 35 degrees. I'm going to draw my eyesight, which is like that. It goes right to the boat. The angle of 35 degrees. Most people are going to think that it's in this bit here. Okay, but that's a mistake. That's the most common mistake people make with this. The angle of depression is actually looking out onto the horizon and then down. It's actually 35 degrees in here. And then I need to find, I already know the height. I need to decide which triangle I want to use. I could use this triangle here, 35 degrees, and then that's 187, and then I could find out what that distance is. Or I could use this triangle here. That wouldn't be 35 anymore, that would be 55, because 35 plus 55 is 90. So I could use this angle and this side and work it out from there. I could get the same answer both times. I'd have to use a different ratio, but in this case I think I'm going to use the top one, because that's already got my elevation angle, sorry, my depression angle. So there, there, and there. And my right angle is just there, 35 degrees, 187 is there. So now I can find out what that distance is there. So what am I going to use? That's opposite and that's adjacent. So again, I'm going to use tan 35 degrees equals 187 divided by x. So I can multiply both sides by x, so I get x tan 135 equals 187. No, not 135, just 35. And then I divide both sides by tan 35, so I get 187 divided by tan 35. Okay, and again, I put that in on my calculator. 187 divided by tan 35. And I get 267.06. And 67.06. And that would be meters, which is actually not really a long way away, is it? Anyway, that's the situation that I found in this case here. So 267 meters away. Okay, so just to sum up, elevation is looking from the person's eye up to the object, so that angle in there, and depression is from the person's eye straight out onto the horizon and then down to the object, that angle of depression in there. Most people will make the common mistake of this one being the angle of depression, but it's not. Okay, so hopefully that's helped. In the next video, I'll have a look at bearings. So thanks for watching.